Hi, I'm Suparna. I automate iOS tests in PayPal. My today's topic is continuous shift left automated testing in native mobile apps, where I'm going to talk about the master secrets, practices, and best techniques that all must implement in mobile automation testing suites. A little about me. I'm a passionate tester by choice. I love solving problems at work. Anything that does not work thrills me. At job, I have been automating tests on varieties of mobile apps from several years now. I have automated apps for different varieties of business domains. I have enjoyed integrating many mobile related QA pipelines. I'm quite multilingual. I help fellow QAs to maximize the testing potential with my occasional blogs. In the meantime, you can always feel free to reach out to me in my LinkedIn profile in case of any queries anytime. Let me walk you through the agenda of today's topic. We will be starting with questions like why shift left in mobile? And then we will be looking into mobile test automation pyramid in detail. How much mobile automation is enough and the right ways to automate. We will be concluding with some of the best practices in mobile automation that is widely used. Let us know what is shift left. Shift left approach helps in finding maximum bugs in the earliest possible development stage, that is as soon as the developer commits, thus saving lot of time and money to business while increasing confidence in the quality of the app. In shift left, quality is a responsibility of all in the team, where testing is integrated within the development phase. If you look at the diagram here, we would be seeing that there is a develop branch in general. And if the developer has to start writing, picking up a story, he will start creating a branch from the developer of feature branch. The developer implements the feature. But after the implementation of the feature, he doesn't merge it. He has to write and sometimes even execute the tests. Now, these tests are not limited to unit, but also integration as well as UI. In most of the cases, they have to make all the test cases pass, without which they cannot merge the PR. And this is shift left, where the developer is not clueless of the issues introduced. The developer creates a branch. This is how he pushes the code. And then because all the test starts running, obviously the new code would have failed some of the test cases sometimes. Let's say there was a bug introduced, he fixes it instantly here. And mind it, we have not even gone to the QA process. This is still in the development cycle. The developer identifies the bug within the same branch, pushes the code with the fix, reruns the tests, and the test passes. He gets the review done, he merges the PR. Now imagine if this test suite was not in place. It would have taken some time to identify the bug, sometimes at a later stage, way beyond few days, which actually got identified within seconds and even got fixed within few minutes. So this saves a lot of business time and the cost of the bug. Now this is the normal process in shift left that gets followed. Here we need to observe that a story is not done until all the automated tests are passing. And that is the end goal of shift left. When we do not identify the right tools and we just pick the most popular tools out there, most of the time we will automate hardly UI tests. Everyone says we are automating, we are testing, but the reality is that they're not testing enough. And yes, it's not enough because they're not automating right. How do you ensure we are doing the right thing? By we are adding value, we are finding the regression bugs. Our test fails before anyone else identifies the bug manually. Remember, the goal of automation always is to save time, to simplify the task, not to complicate things, what's easy. Using the right automation testing tool is very important. And most of us have heard about XCUITest and Espresso, but still do not use it. And that leads to a lot of unused, unautomated scenarios in the testing practice, that is. I'm here to help you today to get the best out of shift left approaches using the inbuilt frameworks of Apple and Google, where we automate the apps in dev environments to achieve maximum value at a very minimal cost and effort. So here we have the environments, where in Android we have Android Studio, because the developers environment is also that. We write our code in developer's environment. That is, all the UI tests, all the automation is happening in the dev environment, be it on the Android Studio or be it on the Xcode, with on using the developer's language. And then a lot is happening throughout, where we can see the automation, the mock thing, the ACI, and then the tracking and everything post-production. Now let's move to the next part. What we have in front of us is a practical version of mobile test automation pyramid. And let us understand this in very detail. We will notice that the unit testing comprises of 60% of coverage. If there is any bug introduced, it should be getting identified here on the unit testing level. Post unit testing, we should be targeting to do integration testing, where we will be able to identify few more integration bugs. Now, having this in place is also saving a lot of time and cost to the business. Post unit testing and integration testing, we will be looking into functional testing part, which is nothing but end-to-end testing in general. So in the end-to-end functional testing, we try to minimize our flows and scenarios into very specific ones, so that we have a very narrower but focused testing suite here. Now, in all of these approaches, we have to keep one thing in mind, that we are reusing each other's code. Let's say something has been written in unit testing, we should be able to use it in integration testing for reusing purpose. Let's say something has been integrated already in the integration testing, we should be able to utilize that in the functional testing or end-to-end testing. Now, if something has been written in end-to-end testing, we should be able to use that in non-functional testing. So before going into the deep depths of what is functional, non-functional integration, we will be looking at the percentage here. So this is how the percentage should be looking like, where the majority of our focus is lying in unit testing. Little more is on the integration testing, narrower it is on the functional testing, even further narrower on the non-functional testing. Very minimal 5% of focus should be going on manual testing, where we will be taking care of key components. Let us go into each of the stages slow and steadily. Now, if we look at the speed and execution and cost, unit testing is the cheapest of all, and they're the fastest of all. And hence, because they're the cheapest and fastest and easy to write, we try our maximum to have the most covered in unit testing itself. As we know, these are generally written by developers. And the higher we go with functional testing, non-functional testing, higher the cost also rises. But we cannot forget the rest of the pyramid here. Let us go through each of the stages of this pyramid one by one. Let us start with unit testing. As we all know, the developers are the writers of the unit tests. While they have been writing efficient unit tests, we also have to ensure that their testing is also adding value. So let us also look into what is something called as visual test, also known as snapshot test or screenshot test. Now, in snapshot test, what happens is that apart from writing unit test, if the developers or the QA community starts concentrating towards snapshot test or visual test, what can happen is that we can save a lot of time in functional testing. Now, let us walk through a sample app to see the demo of a visual test that can be done. We have to remember that this is fully open sourced and we don't have any dependency on any third-party tools. So let us get started. So we have a sample app here, and the sample app looks something like this, where we have an email, password, sign-in button, and the sign-in screen. So basically, if you have to write an UI test here, we have to ensure that whether this text is present, this text is present, this text box is present or not. Are we able to type it? Is the button present? Is the button label present? There is a lot of work happening here, right? But instead of having it covered in the UI test, what if we cover it in unit testing itself as part of snapshot? So this is the agenda of this demo here, where we will be trying to cover this as part of the snapshot test itself. That is, let's say we have written a function, and the function is all about checking whether the login button exists and how it is loading. We have multiple tests written in the sample app, but let us cover how the loading button works. Ideally, the loading button should look something like this. So let us see whether the loading button is still working. Let's assume that there was a code change. And if there was a code change, the impact should not have any change done on the UI part. Without running the UI tests at all, let us run the visual test in our side. Let us run this. We are going to check the snapshot of the loading button. And then we will be checking whether it matches with the previous result that is already recorded. Now our test have run and it has also passed. In this particular case, the test has passed and hence the screenshots are deleted. Let's say the test would have failed. Then how would we debug? We have a few previous failures from the past tests which I have run. There, if we see, this is our reference, which is the recorded version of the screenshot. And here is the execution of it. Now, how do we know which is the right one? Like, it's a very minor detail to our eyes. It's hard to detect in humanly whether the loading button has actually changed. So here we have the difference. And the difference is clearly visible that the loading button, the loading icon has changed in a minor way. And this is the beauty of snapshot test or visual test that is present. So let's say there is a change done in the code level, and all I know that that it will impact the UI, or the test has failed when I rerun the test. So in order to make the changes working, I manually change to true. And then if I run our test again, what will be observed is that the test will fail, but with this message, ensuring that it is letting us know that the record mode is on and it has recorded the snapshot for the upcoming run. Now, if we have to rerun again and check whether our test is running fine, we just have to make it false and run our test, and the test shall pass moving forward. This is a one-time process and it is very easy to use. Similarly, the same can be done for Android. Now, when we configure UI tests, unit tests, visual tests, how do we segregate them? We have to segregate into different targets. If we have to run those test targets in the CI, this is how it would be looking, where we will be building the app, building the test suite, and running all the snapshot tests. And this is how it would look if we run all the UI tests in parallel, that is distributed parallel. Now let us move to the next testing pyramid stage, which is integration testing. In integration testing, we kind of interact with the SDK calls, API calls. We send a request, we receive the response, we validate the response. So this way, what happens if there is any API issue anywhere, it will be caught right here without having to run any of the UI tests. That way, we also save a lot of time in the next levels. Now, API and SDK are two different combinations in mobile. Finally, we are moving to functional testing, popularly known as end-to-end tests. Here, we have to ensure that we use very minimal number of test suites because it's very slow as well. While it is slow, it's also very expensive to implement all the right UI tests because we have to write even maintainable code, implement frameworks, follow design patterns. There are varieties of end-to-end tests that happen here. Now, the UI test that happens on the staging environments, this is widely followed today, although not very recommendable because if something goes wrong due to network call or any lag anywhere in the app, during the network calls, the test sometimes fails. And this is leading to the popular term called flaky test. And then people retry and everything, which is not the very ideal approach to write test because our test should always pass. And if it fails, it should fail only for a bug or for a change, not for flakiness. So let's consider the second and third approach, which is UI test with SDK integration. That is, if we write UI test, let us integrate with the previously written SDK and integrate it with it. So that way we save a lot of UI time as well. So this makes our tests little faster in execution, and at the same time, This is comparatively less flaky. But is it really removing the flakiness completely? Not at all. If our tests were running like 70% fine here, in SDK integration, UI test, in SDK integrated UI test, we have it like 90% flake proof tests. So the ideal way of testing UI is using mock server. So when we say we use mock server, we completely mock the API layers so that our tests are not at all flaky. They always run, they always execute, and they fail only when there is a valid reason behind the failure. Otherwise, they should always pass. So the reliability of running a test and executing it is always 100% in case of a mock backed UI test. Now let us look into this in detail. We all write unit and UI tests. In a shift left, we have the development build sitting with the unit test code, sitting beside another UI test suite. We also have to ensure a few small things here where we are making the test framework quite reliable. We are following all the standards, setting the accessibility identifiers and resource ID in case of Android. We are writing test plans for different test suites. We are writing efficient tests. We are locating all the elements in a different place. And we are also having a good code and test coverage capture. Now, while we are writing a maintainable and clean and reusable test code and enhanced accessibility, we have to ensure that we are following all the right design patterns that we usually follow in any other testing framework. Now, having it integrated to CI is a common practice in shift left. So let us look into the other factors here, which is the network layer. Usually what happens in every automation is that we hit the server. So basically, the network layer plays a very important role in automation, especially in mobile automation, because that is even more critical and even more time consuming and even little more complicated. So what we try to do is make tackle with the network layer itself. So there are 4 different ways of tackling the network layer. So let us go through each of it in detail. The first one being the UI test with hitting the right environment, which is sometimes the staging, the test, pre-prod, and prod environments. So here what happens is that we have the app, we have the test environment, we hit the server, we have the UI test running. Based on whatever happened, it definitely leads to flaky test. While this is what the world uses as part of black box testing, this is not an ideal approach because this is also leading to flaky tests. Retry mechanism is again time consuming and is not adding much value. So let us go through the other stages. The second type of network layer that people use to write UI test is with integration of mock API. Now, in case of mock API, what happens is that the test becomes a lot stable. There is no more any flaky test. This is foolproof all the time. Either your test passes or it fails, and it always works. And if it fails, it works for a genuine reason. It never fails because of flakiness. In mock API, what happens is that it, instead of hitting a real server, we hit a local host, which is hosted locally using the JSON that we have added in our test framework. So this is a lot more in our control and the test runs efficiently in this approach. Now, the most popular mock servers are Nimble, Swifter, Embassy, WireMock, and OK HTTP in case of XCUITest and Espresso. Although there are a lot more out there, and you can definitely go ahead and explore further on this. The usual approach is that we have the app, and then the app hits, instead of hitting a real server, we make the app hit our local server, which is hosted right in our test environment. And then we run our UI test, which is always 100% accurate and reliable. There is no flakiness ever in this approach. And this is widely followed. Now, you might question one thing here. What if our mocks get outdated? We have to write a script to update our mocks on a daily basis. Whenever there is a change, update the mocks. Whenever there is no change, keep the mocks. This way, we will be able to have a very accurate test run on a day-to-day basis. We have the third one, which is UI test with API integration. Now, this is also quite followed. where we hit the API layer, get the response, validate the response, and then integrate to the UI test. This way, we save half of the UI time. That way, we make our test 50% more fast compared to hitting the real server. In this particular flow, we have the app, we make the API call, we receive the response, and then integrate to the UI test. Moving on to the next stage, we have with SDK integration. This approach is very rarely followed, however, is equally as efficient as using a mock API. Now, what happens here is that we make use of SDK library. uh, Now this SDK library comes into picture only when your app is inbuilt with another framework or library. Now, if your app is not using any SDKs or library or frameworks, then we don't have to consider this approach. But in case we know that our apps are using some libraries, it is good to have them integrated in your UI tests with this approach, where we integrate the SDK library, we interact with the SDK tests, then integrate to the UI app of it, and then run our UI test on it. So this approach, what it does is it ensures that it is giving us a full-fledged continuous testing, which gives us the feel of a UI end-to-end test, where we are not really hitting the UI all the time, but at the same time we are ensuring that all the SDKs are working, and the integrations are working, and the UI tests are working as an end user uses the app. So this is also quite efficient. Now, in out of the four, if we have to know which is the most efficient one, it would be most probably mock API, as long we are updating the mock API on a timely and scheduled basis. Now, in case we have to go by the other approach, the most efficient approach would be the SDK integration approach, where we integrate with the SDKs, interact with them, and integrate it to the UI. That also adds a lot of value. The third approach would be to interact with the API, and then the last one would be to hit the staging environment, which is widely black box approach. Now, here we have an example of a SDK integrated UI test. Now, in this piece of code, what we have here is we're launching the app, and then we are interacting with the UI component in the app, and then we are calling an SDK request. And then we are collecting the response, validating the response against the request, and then again going back to the UI layer. This is the approach that has to be followed for UI tests with SDK integration. Now, here what happens is that we are saving half of the time. In many cases, sometimes there are also places where we might be facing issues in integrating or automating using UI. So this also comes handy in places where you want to automate using QR code or something which is more functional in your app. Let's say your app is all about functional. There is hardly any front end. It's mostly back end, 90% back end. In those cases, this kind of testing is widely followed and widely helpful. Why? Because a lot can be happening when we integrate both backend and front end at the same time on the mobile layer. This is a very interesting piece of work that everyone should at least explore once, and if possible, implement in your projects. Now, if we move to the non-functional testing, now what happens here is that we will try to make use of the other testing steps that we have used in the previous stages. Now, in non-functional testing, what Google and Apple have done is that they have given us a scope to reuse our existing test cases. Now, how do we reuse our existing test cases? Let's say I have to do performance testing. All I have to do is reuse my end-to-end testing. We don't have to spend a lot of time in writing new performance tests. Instead, all we have to do is create a new target, reuse the existing components of the end-to-end testing. And the same goes for the localization testing, which comes very handy. Localization testing is one of the highlights of XCUITest and Espresso, because we are already in the dev environment. Developers have already set the localized strings. They have already taken care of the setup. All we have to do is reuse the components of the localized strings, integrate them to our existing end-to-end tests, and that way we also save a lot of time, and we ensure a lot of coverage with very minimal efforts, with lot of reuse of code. Now that performance testing, localization testing is taken care, how do we take care of the security scans? Somehow, if we want to run an inbuilt security scanners, we can do that. However, there are standard practices that can be integrated to CI as well, where as soon as the code is integrated or merged to a particular feature branch, immediately a trigger can ensure that security scans are started, so that the team is always aware of if there is any change in the security layer due to any code or commit. Now, the accessibility testing. While accessibility testing should be a special case, in XCUITest and Espresso, we would have already taken care of it in functional testing, and we will see how. This is a screenshot of accessibility where we can see that we have the hierarchy of the sample app that we have on the right. Now, in this particular case, we are inspecting a button. Now, there are some components that we can see in the button. Components like label, traits, value, and the identifiers. Now, let's say in our case, we identify that there is a particular component that is not having any of these values. In that particular case, what we can do now is, instead of relying on the dev team, we can just go add identifiers in the dev code because we already have access to the code. Now, all we have to do is identify where else we have something missing and just go add identifiers as long you understand and know where to add the code. Now, in this particular case, if we notice, here itself we identify what all is missing and we are adding the identifiers, we are adding the values in the right places. So indirectly, we are also, while automating end-to-end testing, we are also ensuring that we are meeting the accessibility standards, indirectly contributing to an enhanced accessibility in the app. Now, other than running the accessibility scanners at a later stage, if we ensure that while automating, we are also setting the identifiers, we are also setting the labels right wherever they are missing, this also helps us have an improvised app which is accessible. So if I have to print the hierarchy in Xcode or Android Studio, in this case, this is an iOS piece. Here we would notice that some of them have identifiers, some of them do not have identifiers, some of them have labels, some of them do not have labels. So in this particular case, if we see that any of the trait is missing somewhere, then we can just go ahead and add the missing item in the dev code so that it instantly reflects without having any reliability or dependency on the developer. What we can do is, in our test code, we can add the identifiers missing, add the labels missing, and then raise a PR. Anyhow, if the PR is raised in the same repository, developers are going to review the code and going to help you merge it. Most of the cases, it helps you even become a better coder as a QA and helps you get a better visibility of how the dev code has been written. Over the time, it will also improve your accessibility in the app. Now, let us also look at localization testing. What all do we need to take care of? While automating localization testing, apart from reusing the localized strings of dev code and integrating it to the UI, we also have to implement some test plans in place where we configure based on the calendars, the region, the time zone, the languages, and the location. And all of it can be done in the test plan itself. All we have to do is configure them, which are again some inbuilt functions of Xcode and again saving a lot of time. We are doing a lot of testing with very minimal efforts. We are just using components. Now that we have done so much of testing and we have automated all of it, let's say the unit testing, the visual testing, the framework, the API testing, or the SDK testing, and then the end-to-end testing, and then you have all the non-functional testing done, varieties of it. At the end of it, when it comes to the QA, they all have to do is target on the specific items where they can concentrate on exploratory testing further better. They don't have to look at all the repetitive test cases. All they have to do is take care of the most critical areas of the app. They also have to take care of some of the post-production stages like tracking and monitoring during the releases, right? So that also can be automated further. We can add alerts in the post-production site portal, where in case there is an issue, we should be able to identify them. There are different apps out there. We have automated so much, but how are we automating all of this? We are all automating using the basic developers environment. We are just relying on one and only one framework, and that is XCTest and Espresso, nothing else. So the unit testing is happening on XCTest and JUnit, sometimes not even that, just Java. Snapshot test is also using XCTest and JUnit. Now integration testing is using XCTest and JUnit. And end-to-end testing are also using XCUITest and Espresso. Let's say there is a web view component introduced, then we are using UI Automator as well in certain places. Even now, we are not out of the framework. We are still in the dev environment. If you go to the non-functional testing, still we are in XCUITest. We are using the components of XCUITest in the previous stages and enhancing further, saving a lot of time again. So indirectly, and this is just the beginning. This is not like we have covered everything. There is so much which is not even covered even now, and this is all part of shift left. And this is how Apple and Google has contributed in making our testing better in mobile, because the mobile is complicated, and Apple and Google frameworks is making sure that the maximum amount of testing can be done easily. Shift left is all about continuous testing. We don't believe in writing only regression tests or only smoke tests. We want to be more confident in our testing, right? So we have to test everything. So if you have to test everything, how do we scale it? And what approaches do we follow? So what we can do is, because unit testing is fast and cheap, we run all the unit tests, all the snapshot tests in every dev pull request. And the same goes with the integration testing. These are quite reliable. Even if we run SDK test or API test, it would be nice to have it running in every PR level, as long the server is in working condition, because the server has to respond as well. If there is a stable server for testing, it would be ideal to have it running in every PR level, so that we understand how the server is behaving and performing on a daily basis. Now, if we have to run our end-to-end testing, it is ideal to run all the mock tests in every PR. That means that we are running not only unit, not only integration, but also the functional testing, that is end-to-end testing, in every developer's pull request. Now, having that said, we can also integrate the rest of the tests that we have discussed so far. However, these are time consuming. Hitting the server with UI is going to be time consuming, is going to lead to flaky test. So what approach we can do sometimes is, unless there is a small number, if the scale is rising and if there is thousands and thousands of test cases coming up, which is hitting the server every day, then in those cases we can have scheduled runs, which can run once in a day, twice a day, or based on whenever there is a critical merges or release branches. In those cases, we can have them integrated such that we do identify and we do monitor them on a daily basis, but it's not required to be running in the developers PR, so that they are not distracted of the continuous testing in every PR. So this is the strategy that one can follow, is that have all the mocked UI tests running, all the integration and unit tests running in every PR, but at the same time, have all the server hitting tests to be running in a scheduled run on a daily basis, such that if any new issue appears, we know immediately on the same day or the next day, and immediately there can be an action that can be taken. Now, why are we delaying this into the next level is because localization testing, securities testing, performance testing can be time consuming. They run for hours at times, depending upon the type of app you have. So these are time consuming and they take time, and hence it's good to have them running in the scheduled job runs. And then manual testing, because only 5% of the testing has to be done manually. Now our QAs are also much more confident. They can concentrate on only critical areas. How do we integrate it to CI configurations? How do we integrate what we just discussed in CI? The approach is very simple. Apple and Google both have done a tremendous work in simplifying the process. We just have to run one line commands for both iOS and Android. This is the command for iOS, where we run the build, test build on a certain device, and we get the report. That means we are not even working on integrating the report. We are just reusing the reports. That's all. Everything is taken care. And here we have the Android command where we just have to run the UI test. Other than the simulators, there are cloud devices as well, which are not really that open source. However, there are different varieties of cloud devices which we can consider if we have a business need. However, all of them have a common approach. The process is very simple. We just have to upload the app, capture the response, upload the test suite, capture the response, build the app and the test suite, and let it run. Once the run is done, we can always go back and check the reports. Now let us move on to the best practices. How do we ensure that we are continuously testing in the shift left approach is that have a dedicated person for the automation. Why we need to have a dedicated person for automation is because of the business need, because of release, because of other project pressure. What happens is that generally people tend to forget and ignore automation. But if you have a dedicated automation person, they will continue automating no matter what is happening around. So this is one best way to have the automation running all the time so that continuously the testing is not impacted. Now in this approach, what happens, although the developer can automate, can test everything, it is good to have an automation person as well at place. Now the automation person also should not be troubled with manual testing. Then what will happen is, due to manual testing pressure, the person will not be able to automate. Have a dedicated developer, have a dedicated QA, have a dedicated automation person. So that way, none of the process is impacted in any way. Be it one person, but have them dedicated for it, so that no matter what happens, the focus is not lost from the automation. Now, as we discussed, our test should fail only when it is supposed to fail. It should never fail intermediately. It should never fail because of flakiness. It should never fail because of some unknown reasons. It should always fail because of a bug or because of a change that is required due to the latest dev commit. So that is what we say. If our tests are failing, it should fail gracefully. Now we have to have separate test plans. When we start scaling, when our app is having millions of user base, we need to ensure that it is always running in different environment, different configurations. So we need to have separate test plans, and each of the test plans should be in working condition, well managed, well configured, so that no matter what's the situation, we are always covered and confident. If we follow what we have discussed today, we will never see flaky test. Not even one test will fail for unknown reason. If a test fails, it has to fail for a reason. It cannot fail for without reason. And this is a very confident place to be at. And we need to remind ourselves that we are not here to replace the exploratory testing. We're not here to replace the manual testing. We're here to help the manual testing become better, come up with better bugs by identifying and reducing the redundant work, which is getting repeated on day-to-day basis. While writing and having a good code and test coverage, we have to also ensure that we are writing maintainable code, we are writing reusable code, we are writing optimized code, and at the same time, all of them is readable so that anyone should be able to write if time comes. Now, moving to the summary. Parallel automation. Now, this can have two meanings. One, we need to have automation happening side by development. So it's not like automation is happening way after the development is done. Automation should be done at the same time when the development is happening, so that we identify the bugs as soon as it is captured better. Now, in this particular case, automatically, when we are doing so much of automation, so much reusage, so much of coverage, so much of different varieties of testing, automatically it boosts our confidence to the next level. We just know what can go wrong where, and we just know what cannot go wrong anywhere. And because we are continuously automating, continuously testing, the testing process is fastening a lot. It is becoming fastest every time. This is also helping us reach the market every time fast. Everything is automated. There is a reduced human errors. Why reduced human errors? Because when we automate, we also have to ensure that the code is getting reviewed thoroughly by two or more developers or testers. When you have a thorough review process in place, the human errors is almost minimized to a major extent. Now, as we observed in the shift left approach, what happens is that the bug fix happens at the earliest because the test fails at the earliest stage, even before any human eyes have looked into it. In order to merge the PR, the developer have to fix the bug. And that's how we save a lot of business time and cost, and the bug fix time as well. Our tests are more reliable and mature now because there are no flaky tests anymore. When we say accessibility, while writing our test, we are also ensuring that we are adding identifiers, labels, traits, and by doing so, we are enhancing the accessibility of the app. The common repository adds a lot of value for both developers and QA community, because when the dev code and test code is sitting in the same GitHub repository, it becomes even more efficient, clear, and interdependency is also reduced. We can make the changes on the go without an issue, and the changes can be reviewed in the pull request when we raise it. That way, everything is time saving. We have to ensure that our test framework is always robust and low maintenance. High reusability of code is helping us achieve more with less. We have done so much of automation with full of reusability everywhere. We are using all the components everywhere, and that has led to a wide variety of test coverage. Because we're right in the Apple and Google environments, the executions are fastest in the world. Nothing runs faster than Espresso and XCUITest in the world right now. They are the fastest scripting. What I have personally noticed is that when we write any script, any test code in appium, although they say it's a common code, let's say we have to write a script for Android and iOS, people widely try to go for appium, and they say, okay, one code, common code, it should be easy. But ideally, it takes a lot of time to write code for both, so that we have to accommodate for both. Now, something that works for Android may not be working for iOS. We have to handle that for iOS. But here, what happens is that in Espresso and XCTest, the coding time is hardly seconds. We just know what needs to be added. It's never like it's not working. We just know it works, and that's how simple Apple and Google platforms have made testing easy. That brings us to the end of the topic. And what is our end goal? The end goal is to gain inner peace. You just went through the most efficient testing techniques on the planet by automating the right way that tests the maximum with less resources, less time, and more usable code on every app release that is. Even if frequent and fast-paced, still you are at peace. And there's a little bit of tracking and monitoring that is required, and that we definitely do post-production, right? As we go stage by stage. But however, having said that, we are mostly at peace, especially for a QA. This is not something that they're used to hearing, but I can assure you with this today that if you follow what we have just seen, and if you follow each of the stages other than just automating UI test, you will definitely find peace in life in every release. You don't have to have sleepless nights. You will not hear uncertain situations as long things are taken care of. That brings us to the end of the topic. If you have any questions, we will see each other in the Q&A session. Thank you very much for having me today.